Hi friends, this is Kashmira. Today again we are going to deal with a new chapter of second year, that is continuity and differentiation. Continuity and differentiability. As in first year you have studied limits and derivatives. This is the next topic which after the limits which we can continue with this. So continuity here, what do you mean by continuity? In Hindi we can say लगातार, जैसे एक लगातार चीज जो रहती है उसके लिए मैथमेटिक्स में जैसा यूज कर सकते हैं हम लोग, that will be in graph. So suppose this is a graph which is going continuous graph. So next, can pause that now. So this graph is in continuous. So that is continuous graph. Suppose if we take one more graph, and here somewhat it is like breaking here. This break. This is nothing but discontinuous. So how usually we don't go with the graph every time. So what we do is we will suppose if we want to see graph wise also, if we want to see, we have to go with the edge. That is, suppose if I take any function, y is equal to f of x is a function. Suppose if I take x square, how we can show graph with x square values? So you know natural number starts with 1. So I usually we take that. Suppose x and this is y. Suppose if we take the value of x as 1, the value of y will be automatically 1 because 1 square is 1. Suppose the value of x is 2, then the y value will be 2 square 4. Suppose the value of x is 3, the y value will be 9. So on. So in graph we want to show that what we will do, these are the positive values of x-axis, these are the negative values of x-axis, these are the positive values of y-axis, these are the negative values of y-axis. 1, 2, 3, minus 1, minus 2, minus 3. Positive value 1, 2, 3, minus 1, minus 2, minus 3. So here, when we are taking x as 1, y is 1. X as 1, y as 1. X as 2, y will be 4. When x is 2, y will be 4. Same thing, if we go with the negative values, because we have negative values also in the Cartesian form. So suppose if we take minus 1 as x, minus 1 as x. What is y? Obviously, minus 1 whole square is plus 1. So y will be 1. If we take minus 2, minus 2 whole square is 4. Y value will be 4. If we take minus 3, y value will be plus 9. X-axis are negative, but the y value which we are getting is obviously it is positive values. Minus 1 with plus 1, minus 2 with 4. So the graph is like this. So few functions we have where we will get different type of graphs. One more graph I will show you, that is, so this is also continuous, okay? Because once we take the pencil here and we will just draw it, it is a continuous graph, not breakable. That is not breakable, so it is a continuous graph. One more graph we can take, that is y is equal to f of x is equal to mod x. Mod x. Mod means what? Mod in the sense in which the negative value becomes positive. Suppose we have minus 3. When we apply mod to this, the value becomes automatically positive. So that will be like, we will take here again negative values as well as positive values. If we take minus 1, if we apply minus 1 in the mod, the value of y will be plus 1. If we take minus 2, y will be plus 2. If we take minus 3, y will be plus 3. Same. Suppose if we want to take the graph of this, Negative values of x are here, minus 1, minus 2, minus 3, plus 1, plus 2, plus 3, 1, 2, 3, minus 1, minus 2, minus 3. If you are taking minus 1 as x, the value of y is plus 1. Minus 1, the value of y is plus 1. If you are taking x as minus 2, y is plus 2. Minus 2, plus 2. X is minus 3, y is plus 3. Same for if we are taking positive values, we will get positive answer only. So, same thing for 1, 1, 2, 2 and 3, 3. So, here we are getting a parabola type. Okay, we are getting a parabola. Parabola will be the graph of this. So, next, what? Discontinue. What do we mean by discontinue now? This is all about continuous graph. Discontinuous graph in the sense where the graph breaks down. For example, if I take y is equal to f of x, a function with, suppose I will take 1 and 2, both two values. 1 when x is less than 0, 2 when x is greater or equal to 0. X is greater than or equal to 0. Suppose if I want to create a graph, positive values of x, negative values of x, just imagine these values. 1 or 2 values we will write here. Okay. When we are taking the value x as 1, when it is y value, sorry, it is the y value when x is less than 0, less than 0. They are not saying it is equal to 0, but we can do one thing. The value 1, y value is 1 when the value of x, 1 or 2 values we will write here. Okay. When we are taking the value x as 1, when it is y value, sorry, it is the y value when x is less than 0, less than 0. They are not saying it is equal to 0, but we can do one thing. The value 1, y value is 1 when the value of x is less than 0. So we will just round it off because it is not exact 0. Just we will round it off. It is called an open interval. So here we can take the graph like this because we don't know where to stop. This is a discontinuous graph. And one more, y value is 2. Y value is 2 when x is greater than or equal to 0. Equal means we got that it is equal now. So we can just mark it off and we will say the value of y is 2. But we don't know exactly what is the answer. So this is nothing but discontinuous graph. So this is the difference between continuous and discontinuous. But see, here every time we cannot go with the graph and all. So there is a procedure, there is a method where we can solve for this. That is nothing but it is called limits. It is called limits. Limits in the sense what? Some limits we will get, but like some values where we have to stop, we have to find some limit of that particular problem. Suppose for example, y is equal to f of x, or else we can say limit x tends to 3, suppose 3, okay, x tends to 3. Here we will get two values, that is one is tends to or approaches to. Tends and approaches are nothing but same value here. Approaches in the sense almost there. Almost we are there. Suppose 3. We are not saying that it is 3. The value is exact 3 or the value is exact 2. No. The value are almost near to around 2 or 3. Like suppose this is a number scale. 1, 2, 3. If I am saying x tends to 2, that doesn't mean it is exactly 2. It might be 1.999, it might be 2.01, or it might be 2.99 or 3.10, like this. Okay, sir? So now, how to solve for limits? Exactly what to do with the limits, and how we will come to know whether it is continuous or not, continuity or discontinuity. So here, what suppose the sum will be like limits of x plus 2 and x tends to 3 it is. That time what we have to do, we have to take two limits. One is LHL and one is RHL. Left hand limit and right hand limit. As we are not going brief because in first year you have already studied this. So in left hand limit you will take x tends to 3 minus, and in the right hand limit you will take x tends to 3 plus. When the both answers will be equal, then it is called as continuous. This thing continuity we can call it, or else discontinuity. So next we will go with the differentiation topic. So before going with differentiation, you must know few formulas, that is the basic formula of differentiation. Differentiation itself, it is d by dx. The basic formula is x raised to n. That is, in first year we have solved for this the problem 5 marks question that is the expression n into x raised to n minus 1. So x raised to n, differentiation of x raised to n is n into x raised to n minus 1. This is the basic formula by which we can solve complete differentiation chapter. With one more formula we have, many formulas are there. The important formulas will be differentiation of x will be what? We can solve this. Suppose here x raised to 1 is, right? Just substitute in this formula 1 into x raised to 1 minus 1. That is 1 into x is x raised to 0. Anything to the power 0 is nothing but 1. Anything, any value to the raised to power 0 is 1. So what is differentiation of x? That is, directly we can write 1. Differentiation of root x. Now, how to solve this? Root is nothing but half, x raised to half. If I want to solve this, if we want to solve this, you have to again use this formula, that n into x raised to n minus 1, where n is nothing but half. Half x raised to half minus 1. Then, when you simplify this, you will get half x raised to minus half. Take LCM, you will get minus half. When you take that minus half to denominator, it will be plus half again. Plus half. Again that half value we will convert in root, that is x, to root x. So, simple, we can say root x, differentiation of root x is 1 by 2 root x. Okay, these three formulas are very important. Next is differentiation of any constant. Differentiation of any constant. Constant in the sense 1 to 100, A, B, C, D, Z, any constant, if it is single, when we differentiate that, the answer will be 0. Next, we have differentiation of trigonometric functions. That is, differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Already in first year, 5 marks question on this derivatives you are having. So, differentiation of tan x is sec square x. Differentiation of reciprocal of sine cosec x is minus cosec x into cosec x into cot x. Differentiation of the reciprocal of cos is sec x, that is sec x into tan x. Differentiation of reciprocal of tan x is cot x, that is minus cosec square x. So these formulas are very important in solving the differentiation chapter complete. So first we'll go with the problems. Okay, the first problem is find the derivative of first sum sine of x square plus 5. Sine of x square plus 5. How to solve this? First, every time, first step is we have to denote this with y. In differentiation, we have to think as a function. If functions we usually denote by y is equal to f of x. This is your f of x. So y is equal to sine x square plus 5. Now differentiating this. Differentiate y, dy by dx. Differentiate sine. What is the value of sine theta? Cos theta. But x we are not writing because x means this value. This is nothing but your x. Sin x, cos x. X is x square plus 5. We have done with this, okay? Or we have done only with the sine part. What about this? We have to differentiate. Like x square value, differentiating x square with the formula of x raised to n. What is x raised to n? N into x raised to n minus 1, right? What is x square? 2x raised to 2 minus 1, that is 2x. So this 2x, x square, differentiation of x square is 2x. Differentiation of 5 is constant. Differentiation of constant is 0. So 2x plus 0 is 2x. Take out 2x into cos x square plus 5 is your answer. So next problem, that is cos of sin x. Cos of sin x. First, every time we have to denote this with y. Differentiating y, it is dy by dx. Differentiate first value, that is cos. Okay, this is like cos x. This is like x. What is the differentiation of cos x? Minus sin x. But what is x here? This bracket as it is. We have done with the differentiation of cos now. What about sin x? Sin x differentiation is cos x. So this is the answer. Next, we have sine of ax plus b. Sine of ax plus b. First, we will denote it with y. Again, differentiation of y is dy by dx. Sine differentiation is cos. Differentiation of sine is done. Okay, like sine theta, it is like cos theta. What is theta here? Ax plus b. You have to keep this as it is. Then now we have to differentiate ax. What is differentiation of x? A is constant, keep as it is. What is the value of x? Differentiation of x is 1. Why we are not writing a? A is constant. Why we are not writing a as 0? Just because we have some value, some coefficient is there with the constant, that is x. That x value have 1. Answer is 1. So a we have to keep as it is. If it is single, if the constant functions are single, if the constants are single, we can take them as 0. Now this b is 0 here because that is separate, single. Now a into 1 is a plus 0 is a itself. You take outside a into cos of ax plus b. Third is fourth one. Seek of tan of root x. See, 3 brackets, 3 things, 3 functions we have here back to back. So first thing we will denote it with y. Okay, what is the differentiation of y? Dy by dx. First we have to differentiate sec. What is the value of sec x? Sec x into tan x. So x in the sense, this is x for sec. Complete value. So sec x is tan root x, again into tan x. X means again tan root x. Okay, look here. Sec x, this is like sec x. Sec x is sec x into tan x. Sec x into tan x. X itself is tan root x. Now next, what to solve? Next one is tan. What is the value of tan? Sec square x. Tan value is sec square x. Here itself we have to write sec square. What is x again? The tan value. The value of tan. The angle of tan is root x. That is x here. Root x. Done with the tan. Next what left? Root x. Root x, the differentiation of root x is 1 by 2 root x, as I have told. The next we have to arrange this, or else you can keep as it is. Okay. Next question. Next is sin ax plus b divided by cos cx plus d. Now, before solving this, we need to go with two formulas. There are two formulas to solve. That is, one is product rule, one is quotient rule. First is product rule. Product rule means two functions which are in multiplication form. That is like you take u into v. Okay, differentiation of u into v. Differentiation of u into v. First function, second function we can call. First function we have to keep as it is. Differentiate second function. Plus will be there. Second function you have to keep as it is. Differentiate first function. This is the product rule. When two functions are in product multiplication form, you have to use this one. One more formula is there, that is quotient rule. When two functions are in division form, like the sum which we have there, you have to use this formula, divided by v square. We have to take first v as it is, differentiate the numerator, denominator as it is, differentiate numerator, negative value is done, minus, numerator as it is, differentiate denominator. Okay, so this formula we have to use for this formula, this problem. This you have to consider as u and this as v. So we will substitute in this v as it is. V in the sense cos cx plus d as it is. Differentiate u. What is u? U is sin ax plus b. What is differentiation of sin? Cos. What is the cos angle? Ax plus b. Now done with the differentiation of sin. Ax. What is ax? A is constant as it is. X is 1. B is 0. Value will be in between minus. Again, u as it is. U as it is. That is sin ax plus b as it is. Differentiate denominator. That is cos. Value will be in between minus. Again, u as it is. U as it is. That is sin ax plus b as it is. Differentiate denominator. That is cos. Differentiation of cos is minus sin. Angle as it is. And write here once again. Differentiation of cos is minus sin. Angle as it is, that is cx plus d. Done with the differentiation of cos. Cx. C is constant as it is. Differentiation of x is 1. D 0. Whole divided by v square. They have given v square in the sense cos square cx plus d. After arranging, we will get the answer for this. A into 1 is A plus 0 is A itself. Take outside. A into, you write this as it is. Cos cx plus d, cos ax plus d. Minus. This minus and one more minus, this one. Becomes plus. C into 1. C you take outside, write the remaining terms. Sin ax plus b, sin cx plus d. Whole divided by same term. That is, we are not differentiating this. We are keeping as it is. Like this we have to solve for u by v method. Sixth question. Cos x cube into sin square x raised to 5. Okay. So now what we have to do? First we will denote this with y. Differentiation of y is dy by dx. This is like u and this is like v. First function, second function. What is the formula? U as it is differentiation of, differentiation we can denote by dash also, v dash. u as it is differentiation of v as it is differentiation of u. So u as it is will put first, that is cos x cube. Whenever you do differentiation, take the square bracket. Differentiation of v. V is what? See, sine, for sine we can write cos, but it is not sine, it is like sine square. It is like x square here. It's like x square. X square, when you solve, you will get 2x. Right? So same thing, sine square means 2 sine, what the angle we have, you have to keep as it is. Now, if this is done only with square, now what we have to differentiate is sine. Sine differentiation is cos x raised to 5. Done with sine also. What left? X raised to 5. What is x raised to 5? 5 x raised to 4 with using this formula only. Okay, one more time. U as it is differentiation of, this is like x square. X square value is 2x. Same way 2 sine value, whatever value you have, as it is you have to put. Then done with square. What is the value of sine? That is cos. Angle as it is. What left? X raised to 5. 5 x raised to 4 by using this formula. Next, what we have? U plus differentiation of v we have done, right? Plus u differentiation of v differentiation of u. V as it is. V in the sense sine square x raised to 5 as it is. Differentiation of u. U is what? U is cos x cube. Cos differentiation is minus sine. What value? X cube as it is angle. Done with cos, we have to differentiate x cube. X cube differentiation is 3x square. 3x square. Now just arrange these values. First we will write the numbers, then variables and these functions. This 2 and this 5. 2, 5. 2 into 5, 10. We'll take this out, x raised to 4. Then we'll write this cos x cube. Then this sin x raised to 5. Then this cos x raised to 5. That's it. Next is plus into minus, minus. 3 you take outside, 3x square. Remaining you can write as it is. So few more problems we can solve, but in the next video.